Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Vylina. And Vylina, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Do you have all of that social media? Do you have
No.
Facebook, Instagram, Twitter, and YouTube?
No.
Well, guess what? Later on tonight, you're going to be on all of that stuff. All right. Vylina, where do you go to school and what grade are you in?
I go to school at Panama Elementary, and I'm in 5th grade.
All right. Now, you've been at Panama for a long time?
Since I was in transitional kindergarten.
So since TK all the way up through 5th grade. And you almost forgot where you went to school, didn't you?
Yeah.
It's just
That's
school
all right.
at this point.
I was like, whoa, did you just get there
Does it
this
have
week?
a name?
But anyway, so how do you like Panama? Because you've been there for a long time now.
It's nice.
You like it?
Yeah.
They've been doing a lot of new things to that school out there, right? As far as remodeling and stuff. Have you seen any of that?
Some of it, like, before, like, we were kicked out for, like, homework stuff, they had, like, a new playground for the, like, 4th grade up and stuff.
Okay.
5th grade up and stuff. And, like, the right side of the school was, like, already, like, done and stuff, but they were still tearing down, like, the other side of the school.
But you are going to be happy because when you go back, you've got that new playground. 'Cause
Yeah.
you said 5th grade, no, so right?
Yeah.
All right. Well, you know what? I know that you said that you've been working on some triangles today in class.
Classifying
Triangles. So all I want you to do is go on over with Devin, and I want you just to classify the 3 triangles that you started with today. We're not worrying about the types of angles inside of them, but we're going to classify them by sides.
Okay.
All right, so head on over there. You and Devin, you're going to draw them and classify them for us based on sides.
So we're going to start off with our first triangle here. And all of these are approximations, obviously. Hand drawing is an inexact science, but you're also illustrating the length of each side with those numbers. So right here, what you've drawn is a triangle where each side has a length of 3. So what kind of triangle is that?
That is a equilateral.
So an equilateral triangle. So that's the type of triangle that's defined as a triangle where all 3 of its sides have the same length.
They're all congruent.
They're all congruent, absolutely. Let's not skimp on that academic vocabulary. Very good. Okay? So we have 3 congruent sides, which is basically every single side on our triangle. And that's an equilateral triangle. Now, there's 2 other types of triangles that deal with side length.
Yeah.
Okay, what would be another type?
The Scalene triangle. It has
Okay.
two congruent sides.
So one thing you'll start to see as you start to explore triangles is sometimes you won't see side lengths, but there might be a marker here. Like they might draw a line,
Yeah.
those lines, and that will tell you, even if there aren't numbers there, that those two have the same length. So in an equilateral triangle, you might see those lines show up like that. But
Yes.
here we have a scalene triangle. So a scalene triangle,
Yeah,
are we
hold
sure
on a
about
second.
that now? Now,
Yeah, I was
scalene
going to
triangles,
say,
you
because you said scalene, but we're on a different one.
Right, right. So let's think about this, right? Because
Oh,
scalene describes a
Isosceles.
different triangle. What you're describing
Is
here, you said
isosceles.
it's an isosceles triangle, okay?
I don't know how to spell it.
So isosceles. Let's see if we can get this.
That's
here.
pretty
I
close.
believe I-O-C.
Isosceles.
Yeah, this comes from actually ancient Greek. So it's spelled in a similar style. That's how, if you're familiar with Greek and Latin roots, you might remember it. Now, we mentioned scalene. That's obviously, as we mentioned, the third type of triangle. So what makes a scalene triangle unique from isosceles and equilateral?
Well,
So here, there's something very unique about the side length of this triangle. In an equilateral triangle, we had 3 congruent sides. In an isosceles triangle, we had 2 congruent sides. What do we have here with scalene?
we have 0 congruent sides.
You can't even say 1, right? Because the line can't be congruent to itself.
Yeah.
So we have to go straight to 0. So a scalene triangle has 0 congruent sides, where all of the sides have a different length. We're not going to throw any of those marks in
On it,
on a
yeah.
scalene triangle because no 2 sides have the same length.
There you go, nicely done. So wonderful classifying the 3 different triangles right there. We'll get to some more in a little bit. But now it is time for today's Math in the News. And today's Math in the News has a little bit of something to do with yesterday's Math in the News, where we took a look at the parachute from the rover that landed on Mars. And we see a photograph of it right there. And eventually we're going to be able to see a video of that parachute being deployed. And that is happening right now.
Great quality.
So there it is. And the reason this is in the news again is because it was recently discovered that there were some messages on that parachute, but they were written in binary code. So yesterday we went over how the GPS coordinates of the propulsion lab in Pasadena were on that parachute, and we went over how to read in binary and figure out the numbers. So they also have text on there where they had a message. And the message, are you able to decipher? Let's take a look at that parachute once again.
Yeah.
So it'll
figure
be
it
up on the monitor. Do you see any way that you can form words out of that?
Yeah, go ahead and read that.
That's kind of a tough one, isn't it?
Yes.
See, I? No, that's just a line.
All right. But it says,
Oh.
dare mighty things. So
Oh,
what
yeah.
the engineers did is they decided to put this on there and see if other people could figure it out. There were 6 people at NASA that actually knew that this was going on there. And within a couple of hours, there were a lot of nerds, geeks, and things like
Hey.
that sending in, hey, we know what that is. You guys are putting stuff on there. So dare mighty things is on there. And that is a line from President Theodore Roosevelt. And that is a mantra at NASA. And that's written on a lot of the walls and a lot of the buildings. Now, they said that there are also going to be some other things once they start using the extended arm of the rover. When they can see under the rover, there will be some other little surprises, and they're going to see if people can notice those. But let's take a look at going from binary to text, all right? So, Vylina, you can see that there are 8 place values up there, starting with, on the far left, 128. And then we cut it in half to 64. Cut it in half, 32. Keep cutting it in half, 16, 8, 4, 2, and 1. All right? So what we do is we take a look and we figure out, starting on the far right-hand side with the number 1. Okay? Then we double it. In base 10, the number 1 right there would represent the ones place. And the number 2, if you were thinking about numbers the way you normally do, what would the number 2 represent? If 1 is the ones place, what would the 2 be?
The tens place?
The tens place, right? But now here in this, it's the twos place. And the next one is the fours place, and it keeps going like that.
Okay.
And we can see that I listed A, B, and C, and then Z at the end. So A, what letter of the alphabet is A?
The first.
It's the first letter, right? So if we look at the numbers, we only need the number 1. Okay, so that's why we have 4 zeros and then a 1. Because in binary, there are only 2 digits, a 0 and a 1. If it's a 0, it's off, and if it's a 1, it's on. So this is kind of a continuation from yesterday. But you're here today, and that's why you're going to do this one. Okay? So, the letter B. What letter is B in the alphabet?
The second.
The second. So, if we look, is there a number 2 in our place values for binary?
It's in like the one over
Yeah,
to the second.
it's in the second spot, right?
Yeah.
So that's why we have 3 zeros, and then the 1 is on because it's the second place, and the one after it is off because that's a 1. We only need the number 2. Now take a look at C. C is what number letter in the alphabet?
The third.
The third. So we need a total of 3 for a value. The only way we can get 3 by adding things is to go 1 plus 2. Is that correct?
Yeah.
All right. So we need a bunch of zeros, but we need the 1 and the 2 place turned on. That's why there's a 1 and both of the final 2 spots. Does that make sense? All right. Now, how many letters are in the alphabet? Do you know offhand?
26.
There's 26. So Z is what letter?
The 26.
The 26th. So we need 26. So can we use the 128 place if we only need 26? We only have to add up to 26, right? We don't need the 128 place, do we? Too much. Can we use the 64 place? No. Can we use the 32? That's well, that's over 26, right? So we want numbers under 26.
Oh.
So if we look, look all the way over to the right. It says 11010, right, for Z?
Yes.
So the farthest right number is a 0. What place is that in? The 1, 2, 4, 8, or 16? This one right here. What place is that in? The 1s, the 2s, the 4s, the 8s?
The 1.
It's in the 1s, okay? Now think about 26. What is the highest number up here that we can use to help lower 26?
16.
16, right? So we're going to
Yeah.
use the 16, which is why this right here is a 1. Because 16 is in the 5th spot over. So if I go over 5 spots, that value is on,
Okay.
okay? So if I'm starting, I want 26, and I just used 16, how many are left? We start at 26, and we're going to take away 16.
10.
10.
Yeah.
10, right? So out of these numbers, is there a way to make 10?
8 and 2.
8 and 2, right? So 8 is right next to the 16, which is why this is on again.
Okay.
This is what place value? It's the third one from the end,
Yeah.
and it's the 4s, right?
Yeah.
Do we want a 4?
No.
No, we don't, which is why that's off. So we have the 16, the 8, and then you said we needed a 2 also, right?
Yes. Yes,
So
I did.
that's why that's on. So that's how we can make Z. So
Okay.
think about this, okay? So I wrote math up here. What letter, okay, what number does M go with? So what place is M in the alphabet? If you need to, you can count it off and,
If it helps, J is the 10th letter. That's my point of reference. That's what I always use. I know J
right,
is
everybody's got a
10th.
point of reference that
Right.
they can start from. So think about K is 11,
K is 11.
L is,
12.
and M is,
13.
so we need 13. So if you think about the number 13, How up here, using these numbers, can we make 13 without going over?
841.
841, right? So here, right, here's the 1. That's on, because we need a 1. The
Yes.
2, you didn't say a 2, did you?
No.
That's why it's off. This is a,
4.
this is an,
8.
good. And this would be the,
16.
and we don't need that.
Yeah.
Which is why you now are able to read in binary. Right? You need to get the value of 13. Now we know A is 1, right? That's an easy one.
Yes.
What about T? What number is that? Just by looking at this, can you figure out what number it is? There's no 1, there's no 2.
It's the 20th letter.
Yeah.
20, right?
Yeah.
Because you've got a 4 here and you've got a 16. So that's the 20th letter, all right? So congratulations, young lady. You now learn how to read binary. That is today's Math in the News. And we'll have more of this again next week because there's a lot of things that you can find on that rover that actually have to deal with math one way or another right there. We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for a brand new series, A Dairy Delight, The Making of Milk.
Today we are at Echeverria Farms and it's day 1 of our series here out at Echeverria Farms, and I am with Felix Echeverria, one of the owners. How are you doing today?
Doing great, Marylou.
Well, thank you for inviting us out here, and obviously we have a lot going on behind us. Can you kind of tell us where we're at and what you're doing out here?
Well, I'd like to welcome all of you to Echeverria Farms. We're here at the entrance to the dairy. Out just to the front of us here, we have wheat growing in the fields, and that's going to be fed to the cows eventually. And right now we are next to milking cows.
Who are very interested in us.
Yes, yeah, they're very curious creatures. They're Holstein cows, which is basically, most all of our cows are Holstein cows on this dairy. So they're basically black and white. They're known for being good milk producers.
Now you have 2 separations. We have this area behind us right here, but there's also another area over there with a lot of curious cows watching us. Is it the same? Are they the same type of cows on both sides?
They're all the same type of cows. These are mature cows on this side, and on the other side are the younger cows.
So what is the difference?
These cows on the right here are first lactation. They've only had 1 calf. These cows here on the left have already had their 2nd calf. So they're more of a mature animal. These cows here will produce more milk daily on the average than those cows over there.
So
But they're just as curious over there. You
Yes,
can see
they
they're all
are.
looking at us.
So approximately how many would you have on this side?
This dairy is made up, it's 2 dairies in 1. This side of the dairy is considered dairy number 1, and this side of the dairy is considered dairy number 2. We ship to 2 different co-ops, and that's why we have the 2 dairies.
Okay. And then behind us over there, can you tell us what's going on with the buildings over there behind us?
The barn over there, that's where the milking happens, and we've got 2 milk trucks right now that are picking up milk. And it's a double wing barn, so on one side of the milking facility there's 72 machines that milk the cows, and it's the same thing on the opposite side.
So with the cows over here, they're obviously with the milking and all that, how is your schedule with making sure that everything, because you said you belong to the 2 different co-ops, how is that schedule? Because you have to be on a pretty tight schedule, correct, to get that all?
Yes, we milk the cows twice a day here, and milking starts at 5 p.m. and also at 5 a.m.
Okay, and then obviously they're all tagged, so you kind of know which group to take?
The tags reference to they are tagged from the time they are born, so we know exactly where they came from, their parentage, how old they are, any kind of treatments they've had or any issues they've had, and we can follow production along and see how well they're doing.
What is the life expectancy of a cow?
The life expectancy of a cow is about 6 years.
Well, we have a lot more to go over with you, right? Through over the dairy.
We sure do.
But for right now, we're going to send it back to you, Mike, at the studio.
All right, thanks for that, Marylou, and also a big thanks to Felix. He has been a guest of the show before and just very accommodating, letting us out to his dairy and learning all about the making of milk, and that will be a couple of week series that we'll go through for that. 636-4357 is the phone number. We have 5th grade Vylina from Panama Elementary,
Right there.
who has been there since TK. What is the best thing about Panama Elementary? If somebody said, what's so great about Panama?
I like the teachers.
All right, good. Well, that's a very important thing that you like the teachers, all right? So before, you guys were talking about the different types of triangles, a scalene, isosceles, and an equilateral.
Yes.
Now I would like you to discuss the different types of angles within triangles. So
Okay.
you and Devin, go at it.
So we know that there are 3 different types of angles that we can classify based on their side lengths, but we can also classify angles based on their interior angles. What's one type of triangle that we can describe using just its angles?
The right angle triangle.
Okay, so this is a right angle. What makes a right angle unique? I saw you draw a little bit of a square there in the corner. What does that represent?
The
When we say this is a right angle, when we say this is a right triangle, what makes this a right triangle?
the 90-degree angle of which that's
Okay.
the 90-degree angle.
So we're saying that a right triangle has one angle that is 90 degrees. Now that's really important because can we have a triangle with 2 right angles? You
No.
can't really pull
No.
that off,
No.
right?
No.
Yeah, that would you wouldn't be able to bring it together with just 3 lines.
Yeah.
Okay, so we have a right triangle which has a 90-degree angle as part of its interior. Okay, what's another type of triangle then?
The acute triangle. Wait. Yeah.
Okay, so what makes an acute triangle different from a right triangle?
It's less than 90 degrees.
So it doesn't have any angles that are 90 degrees or greater, right? You know, and we want to make sure that we're kind of clear because this can look a little misleading here. Like this looks like a right angle if you compare it to like a lot of square corners here. When we draw triangles and we don't have the luxury of, let's say, you know, let's say we don't have the luxury of drawing, we want to make sure that we're a bit more visual. Now, if we make that change, I don't know if we necessarily have an acute triangle anymore, right? Because if you take a look at this angle, how does this appear in comparison
Oh.
to a right triangle?
It looks like an obtuse triangle.
Now, you mentioned the word obtuse. So describe to us what an obtuse triangle includes.
It includes the peak.
So an obtuse triangle, if you look at that base angle that you have down there, right over this area, this looks a little bit different than a right angle in what sense?
That it's greater than 90 degrees.
Yeah, so an obtuse triangle has at least one angle that is greater than 90 degrees. So let's revisit our visual for an acute triangle. Maybe instead of having an obtuse angle, because once we have an obtuse angle, this is no longer acute, right?
Yes.
Maybe we bring it out down here. Well, no, because is that going to, so acute triangles are really interesting to try to figure out how they would look. So why don't you try a couple of things and see what an acute triangle would look like? Okay. I think visually that might pull it off because that doesn't quite measure up to 90 degrees. If you get a protractor out, you might be able to look here and see that this is less than 90. I might say this is like 80 degrees or so. And these two are definitely less than 90 degrees. So I think that this is a fair representation of an acute angle. And an acute triangle has no angles inside that are 90 degrees or greater. Obtuse has at least one, and a right triangle has one 90-degree angle exactly.
All right, and before we move on, I'd like you guys to talk about how many degrees are in a triangle and how that is easy to kind of remember from a quadrilateral.
That's really interesting. So we talked about the fact that we can't have two right angles in a triangle, right?
Yes.
So let's talk about why that might be the case. If we have this, let's say, for example, we have a right isosceles triangle, okay?
Okay.
So whatever these side lengths are, that's great, and we know that this is a right angle. So we know that this is 90 degrees. If both of these sides are the same length, that means both of these angles are going to be the same, which means they're both going to be 45 degrees.
Okay.
If we add these two angles together, and we add all three of these together, what value do we get?
Oh,
So we can do 45 and 45.
And if you need to,
180.
Oh, 180.
I was
180
going to say, you
degrees.
just write it out on the board if you need to.
We have 180 degrees as the sum of the measure of all the angles. Now, if you add up the angles inside an acute triangle or the angles inside an obtuse triangle, you'll still get to 180 degrees. Now, that's going to be different from a quadrilateral. Let's think of a very common quadrilateral, a square, or even a rectangle maybe. We know that the vertices or the corners of a square or a rectangle is essentially 4 right angles, correct? So what would be the sum of the angles inside of a square or a rectangle?
90 on all sides?
Right, it would be 90 in each corner, so 4 90s. So
Yes.
90, 180,
180 plus 180.
270, and then 360. So
360.
the interior angles of a square, a rectangle, or any quadrilateral, even trapezoids, would be 360 degrees. So you can tell that there is a difference as we increase the sides from a triangle to a quadrilateral of 180 degrees of interior angle sums from the triangle to the quadrilateral.
All right, nicely done. So we'll continue with that in just a little bit, but we do have another opportunity to go visit Marylou and Felix and see what's going on with the making of milk. Mary?
And we are back with Felix Echeverria from Echeverria Farms. Now, Felix, you introduced us to the front with where all the cows are at. Can you kind of walk us through where we're at right now?
Okay, now we've moved into the milking parlor. We're in one of the 2 milking parlors that I mentioned earlier. We're in the west milking parlor. This is the parlor that ships to one co-op, and the other parlor ships to another co-op. So the cows have just come in. It is 5 o'clock right now. This is when we start the milking shift. The cows are milked twice a day, so that right now they are going to get milked once at this moment. So right now the cows are being prepped for milking. They just walked in. As you can see, their udders are full of milk. The machines are ready to go. They're standing on some nice soft rubber there.
And I'm seeing the workers down here. What are they doing to prep the cows?
Okay, there's a gentleman that is going to inspect the milk first. He's going to prime the teats to make sure that the milk is visibly good. And if it's not, then that cow will be separated and moved to another hospital, that we call it, to have that milk separated from the milk that is sold for human use. Right now, these cows were checked. Their milk is good, and this operator is going to apply the machines. And you can see the milk is ready to go. When the cows are first checked, when they prime the teats to check the milk, what happens is that helps to stimulate the udder, and when you apply the machines, the cow will just let her milk down. And when she lets her milk down, the process of milking can go pretty quick. On the average, it takes 5 to 7 minutes to milk a cow, sometimes faster, sometimes longer. Right now in this barn, we're milking the first lactation cows. So these cows have calved for the first time. So their production is good. There won't be as much as a cow that's a more mature cow who's had her second or third calf.
Okay, so I could see the milk coming out right now. And again, where is this flowing to?
Okay, well this is all flowing down into the pipeline down below. First it goes into this hose, and from that hose it goes through a sensor. Now we call these automatic takeoffs because the takeoff process doesn't have to be done physically. It can be manually detached, but when that sensor there, just beyond that black hose, that blue square thing you see there,
Yes.
that sensor right there, when that detects no more milk, that will, that chain that's hanging off the machine there, that will, there's a cylinder inside, an air-operated cylinder will pull that machine right off.
So it's all automatic.
Yes. The removal process is automated.
So once they are done here, and you said this is going to take approximately 6 minutes, correct?
Yes. Uh-huh.
Now where is it going? Through these pipes, where do we go?
From there, it goes into the stainless steel pipe, and from there, it makes its way over to a receiver tank. Tank right here. And this tank has a motor on it, variable speed motor, and there's a sensor here, and as it detects the tank filling, it'll turn the pump on, and then it will pump the milk over to the holding tank.
Can we go to the holding tank?
Sure.
So obviously you have pipes all probably through the ceilings
Yes,
and the.
up in the ceiling, and they're moving into what we call the milk house room.
And is this the milk house room here?
Correct.
Wow.
Yes, because as I explained earlier, we have two milking parlors. The east parlor is that milk is going into this tank right now, and just like the receiver tank over there, this is just a larger receiver tank, and there's a pump here also, and that is going to pump the milk through these filters right here. There are filters inside of here, and these filters take out all the impurities, the dirt, the manure that might be mixed in with the milk. It cleans make sure it's clean milk that goes beyond this point. And if you could feel this is nice warm.
Oh, it is.
Yeah, we just started milking it, and the milk coming out of the cows is 100 degrees, approximately 100 degrees. So it's warm coming out,
Okay.
but it's fresh milk, and that fresh milk we want to cool down as quickly as possible. So we'd like to get that milk from 100 degrees down to 40 degrees as fast as possible before we store it in the large tanks. Now this is a plate cooler right here, and the milk coming in here is coming here at 100 degrees, and once it goes through this mechanism here and that mechanism there, it'll take that milk and drop it down all the way down to 40 degrees.
Wow. And then from there, it makes its way to the tanks, correct?
The same pressure that's coming out of that pump, it runs through these plate coolers, and then it works its way into one of those large tanks there.
Wow. Well, there's a lot more because from those tanks, it obviously goes somewhere else. But we're going to save that because we're going to head back to the studio. When we come back, we're going to talk about what's happening with those milks, where they're going next.
All right, thanks for that, Marylou. Also, thank you to Felix. Don't forget, we do have phone tutors available until 5:30. Devin's in studio, and we have Vylina, a fifth grade student from Panama, working on triangles. And right now, we're going to go to the fifth grade math book, and we're going to take a look at one of the problems in the book. So we want to find the measure of the angles without using a protractor. So young Vylina, with the help of Devin, is going to be able to go through this after you guys just realize that there are 180 degrees in a triangle. So you've got it up on the board, and you guys can go in any order you like, but take it away.
So that's not just a certain type of triangle that has 180 degrees in its interior. It's every triangle. In fact, it might be helpful with a diagram like this to think about exactly how many triangles we're looking at here. So very quickly, how many triangles do you see?
2.
You see 2 triangles.
Oh, 3.
Oh, now there's 3. I think I see anywhere up, I think I might
5.
see up to like 6 or 7 actually, if you think about it. Because all of these triangles break down a lot of different ways. We can go ABE, we can go BEC. ABC is its own triangle. In fact, it's a certain type of triangle that I'm looking at. But how about these right here that goes to BDC or BEC? Like, there's a lot built in within just this one before you even get to this larger one. They're all triangles. And what do we know about all triangles and their interior sums?
They all have 180 degrees.
They all equal 180 degrees. So, with just the information we have here, we could find the measure of every single angle as long as we have 2 of the 3 of any triangle. So, let's just play around with that. Do we know of any of the missing angles just by looking at the other 2? Let's start off here with triangle ABC. We have 2 angles here. We have 60 and we have 60. What does that tell us about this angle here for this larger triangle?
The,
Well, let's put it to you this way. We know that whatever those 3 are, we know that A is 60, and we know that C is 60, plus whatever the angle of B is, whatever the measure of the angle B is, we know that that's going to equal 180 degrees, right?
yeah.
Okay, so how can we find out what this measure is, knowing these other 2?
You could add 60 and 60 together. Then minus that from 180 to find the missing angle. Oh. Wait.
So 180 minus 120, well, let's look at that tens place again. 8 minus 2, right?
Oh.
So that tells us that the measure of angle B is
It's
60
60.
degrees. So we can use the existing 2 to find the third, right?
Yeah.
Okay, that's great. If you take a look at these descriptions for these angles here, what they do is they use 3 letters. The way that that works out, it's almost like tracing a path. And it's going to tell you exactly which angle they're describing. So when we see angle ABE, what we do is we kind of trace a path here. A to B to E. So what we're really describing here is this angle right there. Just this angle right here. Now, we said that if you know 2 out of the 3 angles of a triangle, you could find the third.
Yeah.
Let's take a look at triangle ABE and see if we have 2 out of 3. Do we have 1 angle that we know?
You have A.
Okay, we know the angle A here is 60. Great. Is there a second angle that we know?
B.
Well, we know B if it's all 3 of these added together, right?
Oh.
But
Okay.
just this little piece by itself, we don't quite know yet. Let's take a look at angle AEB here, over here.
Okay.
Do we know the measure of this angle?
No.
It doesn't tell us a number, but is there any other clue here that might
Oh.
give us some information?
That box right there infers that it's a right angle.
And if it's a right angle, what is the measure in degrees?
90.
90. So we actually do know a second angle here. So whatever that angle B is, when we add 60 and 90, we have to add that third, and that'll get us to 180. Now, we did 60 and 60, and that got us to 120. So real quick, without writing it down, what do you think 60 and 90 might be? Well, let's think of the difference between 60 and 90, right? What do we add to 60 to get to 90?
30.
So if we add 30 to 120, wouldn't that be the same thing as adding 60 and 90?
Yeah.
So what would that be?
150.
So if we have 180 minus 150,
You'll
Well-
get 30.
30. Great mental math there. So we know that this angle right here is 30 degrees. Angle ABE is 30 degrees. Great. Now, we also need to find angle CBD. Again, following the convention of how we label, yeah, you're pointing to it right there, C up to B, and then go into D. Now, we had an interesting conversation about measure B here. We said that this whole thing was 60 degrees.
Yes.
So we know that this angle is 60 degrees. We also know that this is 30 and this is 15.
Yeah.
So in order for this whole thing to equal 60, what does this have to equal?
Whole thing to equal 60.
So we have 30 and 15 here. Just those two by themselves, what do they equal when we add them together?
100.
Well, just
40.
30 and 15 here, right?
145.
Well, this isn't 115.
Oh.
This is just the angle of 15.
Oh,
Yeah.
45.
This is 45. So we know these two together are 45. And we can kind of use the same mindset here. 30 plus 15 plus something, we'll call that angle CBD, is going to equal 60 degrees. And we know these two are 45. So 45 plus that angle is going to equal 60. So what does that angle have to equal?
45 plus C, which means it's going to have to be.
Well, we can also figure it out by taking 45 away, right?
Yeah.
So we can do 60 minus 45. That's okay.
15.
15. Now, here's a way that we can check to make sure that this is, in fact, the measure of this angle. We now have all three angles of triangle CBD, or triangle DCB, or however you want to call it. If we add these three together, what should they equal, since those are the three interior angles of a triangle?
180.
So we can decide which two to add first. Which two of these would you like to add first? 105, 60, or 15?
105 and 60.
105 and 15, okay. 105 plus 15 equals what? You want to work through the place values here? So 5 plus 5 is?
10.
Okay, we'll bring a 1 up here. We have 1
20.
plus 0 plus 1, yeah.
120.
Now, if we add 60, do we get to 180?
Yes.
Sounds good.
Good.
So,
Now, you guys have two of those complete. You're well on your way to finishing all of those, but I know that we're doing math in our world, but there's also some math to do in the other world. But before we do that, you've been doing some great work today, haven't you? You feel pretty good about what you're learning today?
this is some higher level stuff here. They're not getting
Yeah.
this to you in 6th grade.
Yeah.
Well,
Here
you know
right
what?
now
For your
for
great
grade
work so
beyond.
far today, you've got yourself a meal
Oh.
courtesy of our friends at Broken Yoke, so congratulations on that. And we'll check out some of that math in the outer world right now.
Hey, Globey, I'm gonna catch a meteorite. That's right. Any minute now, a meteorite is gonna fall from the sky. I'm gonna be right here to catch it. That's right. Any minute now. Okay, we actually might be here for a while, because you see, even though meteorites fall to Earth every day, we might have to wait around for over 1,000 years or so to actually catch one in this spot. Since this show's roughly about 5 minutes long, I better get right to the point. Today we're going to learn about how NASA's been studying meteorites and comet dust to learn more about our world. Dr. Mike Zielinski is a cosmic mineralogist at NASA's Johnson Space Center in Houston, Texas. He studies rocks from outer space. These space rocks are called meteorites and are basically samples from other worlds. These samples contain the materials, like carbon, that make up our planet and other planets in our solar system. Scientists call these materials the building blocks of the universe.
All the compounds that make up you and me and and all the world around us are in this rock. I mean, it isn't alive, and it was never living, but all the building blocks of all those things are in here. So we think that the Earth and the moon and the sun formed from rocks just like this. And so by getting these, collecting them, and bringing in labs like this one right here, and analyzing them with things like this machine right here, we can find out a lot about where all the planets came from, how they formed, and maybe a little bit about where we came from as well.
So how do mineralogists like Dr. Zielinski find these meteorites? Well, some of these meteorites have already fallen to Earth. So where are the best places to find them? Places like the desert are great because they don't contain rivers or oceans that could hide the meteorites or wash them away. Also, most people don't want to live in the desert, so sometimes these meteorites go undiscovered in the deserts for thousands of years. But the best place on Earth to find meteorites is at the South Pole in Antarctica. The area is cold and dry, and until recently, humans rarely went to the Antarctic. So there are many meteorites waiting to be found there. In fact, some of these meteorites have been lying there on the ice for millions of years. Dr. Zielinski is part of an important mission at NASA to study other kinds of rocks, tiny little particles that can be found in comets. Let's ask Dr. Zielinski what a comet is.
Comets are icy objects, and you see this is a chunk of a very, very cold ice, special ice called dry ice. It's super cold, like you have in space, and there's rock attached to it here. And this sort of thing, this is where most of the rocks from space come from. They come from real icy, rocky objects that are orbiting the sun, and they're mostly composed of ice here, which is frozen gases and frozen water. And these comets are always flying around the sun, and they're giving off particles.
So how do scientists like Dr. Zielinski study comets? I mean, how do you actually get a sample of a comet? Stardust is the name of a mission created by scientists all over the United States in cooperation with NASA. The purpose of this mission? To investigate a comet called Wild 2. Interesting name, isn't it? During the Stardust mission, a spacecraft was launched from Earth on February 7th, 1999. It took 7 years just to complete the mission. The Stardust spacecraft traveled nearly 4.8 billion kilometers to reach the comet. We could make 6,000 trips to the moon and back before we traveled that far. Once the spacecraft reached the comet, it opened up like a giant collector dish to capture samples of the comet's dust.
Well, it's more like a catcher's mitt. The clamshell opened up, the catcher's mitt came out, and as the comet dust grains smacked into it, it's like catching baseballs, thousands of baseballs, but very tiny microscopic baseballs. These grains are smaller than the width of a human hair.
This comet dust was collected in a substance called aerogel. Aerogel is so light that when you hold it in your hand, you can't even feel its weight. Aerogel begins as a gel, much like the gelatin you eat. The material then goes through a special process where the liquid is taken out without collapsing the gel. The result is an amazingly strong, lightweight material. 7 years after the Stardust spacecraft was launched, it returned to Earth on January 15, 2006. Scientists then had access to all of this comet dust that was stored in the aerogel.
Basically, everyone here is very calm. So you know how some of your friends are like constantly like this, they just can't settle down right? And some people are really calm, you know, they're really all like this all the time, kind of laid back. That's how we are. And people like that can very carefully take little pins and just pick up little microscopic things. You do it under a microscope and move from place to place, pick them up, set them down on places like this microscope like this to study. And so it takes a special kind of person who's very calm and they're very hardworking, but a lot of people are like that. So a lot of kids out there watching this, I'm sure this is the job for you, right? Not everyone, but for some people who are really curious about what's out there in space and where the Earth came from and really have the drive to learn about it.
But the mission was worth the time and effort. Scientists like Dr. Zielinski discovered not only the dust they expected to find in the aerogel, but small crystals as well. And by studying these small crystals, scientists have already changed some of their ideas on how and where comets are formed. So, Globey, today we learned that meteorites and comet dust contain particles that are the building blocks of the planets in our universe. And when scientists get the chance to study these particles, they can find out more about our own world. Maybe one day you'll get to find a meteorite. And remember, if you hold one in your hand, you're holding something that may be millions and millions of years old. Maybe even older than Earth itself. That's pretty cool, isn't it? All right, let's go. Come to Papa.
That'd be interesting to see the impact on that mitt as one of those meteorites hit it. But anyway, meteorites start as meteorites. Once they hit the atmosphere of Earth, they are meteors, usually dissipate in that time. But if they hit Earth again, they then become a meteorite again. So it goes from meteorite to meteor to meteorite. But Vylina, you've got 2 more angles you need to work on. So you and Devin, go ahead and finish that problem up.
You know, during our break, we talked a little bit about exactly what we meant by those last 2 angles down here, EDB and BGF. And we actually had a really good conversation about using using the path of those angles to find out what exactly we're talking about. So let's talk about EDB. How would we find the measure of angle EDB? We talked about needing 2 of those measures to find the third, right?
Yes.
So in this triangle, EDB, do we have 2 of those 3?
Yes.
Okay, which ones do we have?
We have B and E.
We have angle B and angle E. So we know that B is 15. What is angle E?
Because this thing is right here, it means it's a 90.
It's telling
It's
us that that's 90 using the
Yeah.
visual. Okay, so we know that this is 15 and 90, and we know that the whole thing needs to equal 180. So how would we figure that out? So she's going to add the sum of the 2 known angles, 15 and 90, and that's going to bring us to 105. Now, if the 2 angles we know equal 105, how do we find out the difference between 105 and 180?
We subtract 105 from 180.
So when we subtract these 2 from the 180, we'll find the missing angle of the third. So let's subtract. We'll go ahead and begin with the 1s, with the 0 and 5. Turn that into a 10, bring a 10 over from the 10's place, so that 8 becomes a 7 in the 10's place. And that brings us to 75. So that means that angle EDB
Is 75.
75 degrees. Great. We have 1 more left to go, and we finally get out of this triangle and go bigger picture with angle BGF. B, whoop, G, down, and F up here. Now, it's a big triangle. Do we have 2 of the 3 angle measures that we know?
Yes.
Okay, which ones do we know?
B and F.
So B is 15, and F is 45. So we know 15, we know 45. Do your magic. So we know that those 2 that we know are 60. So how do we use that to find the measure of the missing angle?
We subtract 60 from 180, which gives us 20.
Let's not neglect
Wait.
all of our place values here, because we've gotten
Wait,
the
well-
10s and the 1s.
Yeah, sorry.
Well, we don't need to necessarily borrow. We know 0 minus 0 is...
Yeah, you were on the right
yeah.
track there before.
Yeah. We did, we
Yeah.
ran the 100-meter dash, and we got to 95 yards out.
I got confused.
So we got 0, we got 2. There's 1 more step here. So we know that the measure of angle G here is 120 degrees.
Yeah.
As long as you know the 2 parts, you can find the third.
Yes.
And nicely done. That is
Woo!
a very, very difficult problem to start with triangles on your very first time. But we've got you all set for class, because you're going to start doing that, and you'll be all set for that. We do have 1 more opportunity. We're going to go visit with Felix and Marylou and continue with the making of milk. Marylou?
And I am back with Felix. Felix, we were kind of just talking about how the milk is regulated and all that. Can you tell us where it goes from here, where we're at right now?
Well, now we're at where the milk is stored. We've gone through all the milking and how we got here, but now these tanks here, and there's 4 of them, each tank holds about 14,000 gallons of milk in each tank. So that works out to about 2 loads of milk that's held in each tank.
Could you tell about approximately how many cows that would be?
Well, each cow produces about, we're averaging about 9 gallons a day. So you have to do the math.
That's okay. So
I'm not sure how many cows it would be, but it's...
So from here, in these tanks, what's happening?
Well, from here, right now, we've got these tanks. This tank right behind us right now, this tank right here is being pumped into a milk truck as we speak right now. So this tanker out here will take about 6,000 gallons of milk and deliver to wherever it's going.
So I'm seeing the tube into the wall here. Is there a certain where it knows from which tank it's taking it from?
You can see from right here from the bottom. This is the bottom of the tank here. And that milk is coming in through this pipe, working its way over to the wall here. And there's a valve that's open, and it's going through this pump. And from that pump, it's being pumped through this hose, and this hose is going directly out to the truck there.
Can you go back there to the truck?
Sure.
So we see the tube coming into the truck.
Yes, this is going right into the truck here, and this tanker will hold about 6,000 gallons.
Okay, so once this is filled, then do they switch it over to the other because you're filling?
Yes, we're this dairy at this moment right now we are shipping about 8 loads of milk a day.
Okay, and you said 6,000?
There's about 6,000 in there, another 6,000 there, so
we have about
48,000 gallons of milk a day that are being shipped.
Wow.
And that's every day right now. So every day there'll be 8 trucks here taking the milk to market.
Okay, so it doesn't go straight to market. Where does it go?
Right now, some of it will be going to Southern California for bottling milk, and some of it will be going north of here for making cheese. But there's also cheese making places down south too. So it is going to both. I don't know which one it's going to. We belong to a co-op, and actually we belong to 2 different co-ops. And those 2 co-ops do the selling of the milk for us.
Oh, wow, how interesting. So 48,000 gallons leave a day here.
Correct.
And then you're milking the cows 2 times a day, correct?
Yes, 2 times a day.
Wow.
And each cow produces on the average about 9 gallons a day.
Wow, that's interesting. Well, Felix, thank you so much for walking us through the milking process today. It's been really interesting to see how it starts at one place with the cow, and it processes all its way to the tanks, and then gets sent to the stores. Thanks
Very
again.
welcome, Marylou.
All right, well, that's it from us today from Echeverria Farms. Back to you, Mike, at the studio.
All right, thanks for that, Marylou. We will continue that series next week with Felix. And Vylina, a 5th grade student from Panama, has been in studio today. What did you learn today? Like, what do you keep in mind?
We learned the binary code today. I never learned that before. And how to measure angles.
There you go, because you learned about triangles today in class,
Yes.
but now you've got the angles down, so you're a little bit ahead of where you're going to be in class. So when you do this in class, guess what?
I don't know what to do.
You'll be able to help the instructor, right? Help her
Yeah.
out and go along with that, right? Did you have some fun today also?
Yeah.
Good. Well, I'm glad you
It's
did
fun.
because we certainly enjoyed having you on the set today. We do have phone tutors available until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.